Dear friends, welcome to my video. In this video, I'll show you how to compute the GCD, greatest common divisor, or HCF, the highest common factor of the numbers in your Android app. So let's begin. So we'll create a very simple layout and I'll just name it as my GCD application. We'll give a space here. Rest of things I'll leave it as it is. I'll use API 26 level and click finish. It may take some time to create the environment. So in parallel we'll see the wiki page of GCD. So GCD is nothing but it's the greatest common divisor of two or more numbers. So it's which are not zero and is the largest positive integer that divides each of the integers. So for example, the GCD of 8 and 12 is 4. So we'll compute this. There are various algorithms to solve this. So we'll use a very simple algorithms. But if you want to understand more about the algorithms, I will suggest you go through different online materials on that. And there are like algorithms called Euclid's algorithm, which is one of the most popular one. But in this video, I will not show you to implement Euclid's algorithm. My aim is to just show you how you can implement such kind of algorithms in a very simple way in your Android app. So let's begin. So this is the layout which should come once you create your environment. So we will proceed with creating a very simple layout first. So in design, probably I don't need this, and I'll maximize this so that we can see it in a bigger screen. Yes, so I'll just remove the text view, or probably I don't know. I'll need a button definitely to compute. I'll put a button somewhere in middle. And what else? Probably I'll need a input plain text. Probably I can use where I will input the numbers in string format, which will change to integer format in our Java code. And then at the last we'll use we can use probably text view, which we deleted by mistake, but we'll use this to display our results. So that looks good. I'll just move it a little bit up so that everything is on the top part. Yeah, so I will not spend too much of time on this layout. I'll just keep it simple. So first let me fix this, and edit box looks fine, the name, but this name I don't need. I'll just put a hint over here somewhere for this one, and hint will be enter the number here. So this is the in gray you will see over here displayed. Perfect. Then apart from that, then we will use this button, and button again I'll first fix the layout by putting the constraints, and the idea remain leave it as it is, but a text displayed on button probably I will change it to calculate or GCD, or you can use anything. Yeah, and then the last is text view. Here again I'll first move it a little bit up again, not so close, a little bit down, looks good to me. And then I'll put constraints as usual, and the text will be not text view but results or result. Yes, and what else? Probably I'll increase the text size. Is very small over here. So let me see if there is any so for text size, what I'll do is I'll just search in this, and then text size from 14 to probably I'll increase it to 24. Yeah, it looks bigger now. Okay, perfect. So before I think there are a few warnings, and those warnings are for the resources which we created. So we can do this autofix here. The first one was for the autofill of the edit text box, which I did yes. You can choose as per your requirement. And then for the 3D text which we have used in our layout, the one was for the hint of the text box, the second was for the button, and the third one is for the results. So we'll create the resource in the strings XML file, so that will go and sit in the resource layout. Okay, no, I think values and then strings.xml. So these are the variables which we created just now by using the autofix option. So more or less our layout is finished. So we'll just run it in parallel in one of the emulator, which will come which will put it in the right hand side. And in parallel now we can move to our Java code. I think we don't need XML to be open. We'll just layout is fine. And now in Java code we can start. So in Java code, first and foremost, I'll first create a method which will be called whenever that button is pressed, the calculate button. So public void calculate button view so there is some alt plus enter. If I press it, automatically includes the required packages, so that's fine. So now we will do one thing, we'll just add this calculate button as a on click method or on click attribute to this particular button. So once I come here, I think I should remove the search text, and then on click attribute should be somewhere for this button over here, so I can see it over here. Just click on this drop down menu and you'll get this method which we just now created. So in parallel, you are also seeing our emulator has come up, and so our layout has come up on the right hand side, and now we can begin our coding over here. So we have already given the method which we just created as an on click attribute to this button. So whenever we click this button, this particular method calculate button will be this particular method will be called. So before we proceed, we'll first create some local variables which will get associated to this widgets which we have created in our layout. So one is the edit text, and the other one is the text view. Text view is for the result. Text view. Okay, and then on create method will associate this edit text find view by id r.id dot I think it was edit text in that also. Yes, the name was same, and same will do for text view find view by id r.id dot text view. So once we have got this associated, I don't think we have to do much over here. Now we can start our algorithm over here. So we'll keep the algorithm very simple. As I told initially, there are lots of algorithms out into the academics. You should read them, but here I'll choose one of the simplest ones. So the algorithm I'll choose is, I'll first sort the numbers which are entered over here into increasing order, and one by one I'll check for all the integer values starting from 2 to the smallest value, whether that is a GCD or not. Probably let's see in our code, and then we'll understand better. So first we'll create a string array. So strings numbers. So how we'll create it is, we'll get the input from edit text get text, and we'll split it. First, of course, we'll have to convert it into a string format just to be on safer side, and then we'll split it based on comma. So whenever there is a comma in this particular entry by the user, we'll consider it as a separate entry, and that will be considered as a separate element of our string. So once we have the array of strings, which is nothing but the array of numbers in the string format, now what we can do is we can convert these strings into integers. So for that we'll have to use integer parse init method, but before that I'll create a integer array probably. So integers numbers, and then over here what I will do is we'll create a new integer array, and the length of this will be whatever the length of the array which we have in the strings. So we'll just choose the length, and that's it. Now to convert the strings into numbers, we'll have to use some kind of loop. So here what we'll do is probably for int I equal to 0, I less than, we can use that length again, strings dot number length. We could use the length of integer numbers also, because the length of this and this is same, no? And I plus plus, because one by one we will parse each and every string numbers and put it into the integer numbers. So we'll do is integer numbers of I equals to nothing but integer dot parse int, and we'll use the strings number to parse int. That's it. So this loop will make sure that all our strings are converted into an integer format into this string integer array, And now we can use this array sort method, arrays.sort method, and we will give our integer as an input, integer array, which is nothing but integers, numbers, and this will sort our integers into an increasing order. So once we have our integers sorted out, now we can start computing our GCD. So we can put or initialize a variable called GCD. GCD will be minimum 1. It can't be 0, because for even if you have all the prime numbers, or even if you have only one number, then also the GCD will be at least 1. So we'll start now. We'll again have another loop for I, or probably I don't, yeah, for int I, and over here we'll start this integer from not from 0 but from 2, because what we'll do is we'll compute or we'll consider all the numbers starting from 2 to the smallest of the numbers which are entered here. So that we'll consider each and every, say for example the number entered is 5 and 8. So to compute a GCD we'll have to consider 2, 3, 4 and 5, because any number greater than or equal to 5 will never be a GCD, because it will be more than the smallest number. So we'll start with the smallest number, which is 2 here, and we'll go up to the largest number, which is nothing but I less than and integer numbers 0. I think it should be less than equal to, because we'll also consider the number itself. So say for example if we are considering 4 and 8, so in 4 and 8, 4 is a GCD of 4 and 8, so we have to consider 4 as well. So now we'll go I plus plus. Yeah. So this is the first loop, and over here we have to we will check for each of these numbers what we are considering, whether it's perfectly divides the each and every element or not. So we'll have another loop for int j equal to 0, j less than the length of whatever the length we have considered. So this time we can take integer numbers dot length, and it should be less than, of course, because we won't consider the last element, because the indexing starts from 0, and j plus plus. Perfect. So now once we have it, now we can, what we can do is we can check whether this particular number, whatever we have considered here in I, whether it is a perfect divisor of all the elements or not. So for that we will consider if the integer numbers, and which we are iterating on the jth index, whether it's a perfect, if this is equal to, or rather, so what we can do is we can have another flag here. So whether the int is, so we'll have a flag called int remainder. So and we'll put this remainder as a start as 0 at the start. Perfect. And if this is not equal to 0, which means it's not a perfect divisor even for one of these elements, so what we'll do is we will just set this int remainder as 1, and we'll break this first loop. We don't have to unnecessarily just keep iterating for others, because the moment it is set for if it's not dividing even a single element, we can just skip it. I don't know why it says, okay, I think I missed it 0 over here, that's why it's giving red mark over here. So I think more or less that's fine, and the moment it breaks, it will go again in the second loop, but I mean this for loop will be broken. But if what if the integer remainder is 0, then our GCD, so I will put another if here, if int remainder, no, not integers but remainder, int remainder equal to 0, so what will happen is our GCD will change, and GCD variable which we have assigned over here as 1, this will be nothing but it will become I, because that's the new GCD we have got. I think that's it, nothing more we have to do. So we can just now come out of this for loop, and over here we can just set our final this result. So this is nothing but text view dot set text, and that will be the this GCD value, but this should be converted into string format. So for that we can use string dot value of it's not coming. I think this v will be small, value of, yes, and this value of will be nothing but GCD, which we have. Yeah, so this will convert my integer into a string format. So that's all. Let's rerun and see if it works. So first we can let it complete. So first we will start with a simple example. So I'll repeat. So there are various algorithms, but the algorithm which I have used here is I just iterate through the smallest number. So till the smallest value. So in, say for example, if the numbers are 4 and 8, I'll iterate for all the values from 2 to 4, 2, 3 and 4, and then we'll check one by one for all the other elements of the of this given inputs, whether they are a perfect divisor or not. If not, then it goes through and if it is yes, then it reassigns the GCD value. So first takes our simple example, 4 and comma. I don't think I have to give 2 or only 1 comma is sufficient, and then 8, and I'll do a calculate GCD 4. Perfect. So now I will give another probably 18 comma 6 comma 32, and now let's see what happens. 2, yeah, because 18 and 6 are not divisible by 4, so these are divisible by 2, whereas the others are divisible by 4, so it should be 2. Now we'll take some other examples. Say for example, I'll take 11 and 7. 11 and 7. So in this case also, if you debug the code, what it will do is it will scan your all the elements from 2 to 7, because 7 is the smallest number, and the answer should be 1 over here, because none of the number between 2 and 7 will be able to perfectly divide either 11 or 7. So GCD, which is initialized as 1, which is getting printed over here at this line number 55. So we can try it with some other examples as well. Probably I will not use 7, I'll use something like 1111 and 121. So let's see, I'm expecting 11 to be the answer. Yes, perfect, because this 1111, 1111 and 121 both are divisible by 11 perfectly. So that's how we get the answer 11. And so probably what I'll do is I will just have another example of, say, from 32 comma 6 comma 30. Here again I am expecting 2, and probably I'll take some bigger number, 1000, 25, 25, 225, 125, 25. Yeah, that's what I was expecting, because 25 divides everyone. And what if I remove this 25? Then also I expect 25, because all other numbers are still divisible by 20, only and only 25 is what I think. Yes, 25 is the number. But in this second case, what it would have done, it would have computed all the numbers up to 25, because 25 is the smallest number, and then but it finds only 25 to be the GCD, and it prints 25 as the GCD. Perfect. So that's all I wanted to show you. So yeah, before getting into this app, I'll suggest that you go through the concept on various forums on the internet and understand which algorithm you want to implement. I just wanted to show you implementation very simple, and yeah, you can just simply do it like this. So here what I'm doing is, here I first initialize the GCD as 1, because GCD is always the smallest GCD is always 1, greatest common divisor of any number, and because 1 is the universal divisor. And then I put a flag, it's a kind of flag integer, so we could have taken boolean also, not a big deal. And then I'm iterating to all the numbers, the smallest number. And why the 0th is the smallest number? Because over here we are sorting it out at line number 35, and once it's sorted out, and then we are initializing the flag as 0. But if we find that it's not a perfect divisor, which is not equal to 0, this particular element I, then we just break it, making the remainder as 1, so that it doesn't get assigned to the GCD value. Perfect. So I hope this video is useful. In this video I am not showing too much on the app perspective, but it's more from the algorithm perspective. So I hope this video is useful. You will find the details of this code and all those things on my website, programmerworld.co. Please visit that. And if you like this video, then please subscribe to my channel. And if you have any questions, suggestions, please put in the comment section. Thank you for watching, and have a nice day. Bye.